All right, so we're going to continue section 12.5 and one more note from the section, and then after that we'll switch and we'll go into doing some examples. So given a curve R of t, the binomial vector is perpendicular to both capital T of t, so the unit tangent vector, and capital N of t, the unit normal vector, and is given by capital B of t equals capital T of t cross capital N of t. So if you have those, you can just take their cross product, but it takes a little bit of effort to get both of those, because remember, for T of t, you have to do R prime of t, and then the magnitude of R prime of t, take that quotient, and then here you have to take your T of t, take its derivative, take the derivative of that. Take the T prime of t, the magnitude of T prime of t, divide by that. So finding these quantities to take this cross product can be a very involved process. So you can also compute B of t by just taking V of t cross A of t divided by the magnitude of V of t cross A of t, which may be less involved or may not. So either one of these approaches works to find the binomial vector. All right, so now let's look at some examples from your textbook, and we will start on page 794. We're going to start with number 2. So page 794, number 2 says, in exercises 1 through 10, first show that the magnitude R prime of t is as given, then find the tangent and normal of the curve parameterized by R. All right, so I presume they mean the unit tangent vector and the unit normal vector. So 2, they give us that R of t equals cosine cubed of t and sine cubed of t. And they tell us for t between pi over 6 and pi over 3. So t is between pi over 6 and pi over 3. And they give us that we're to check that the magnitude of R prime of t equals 3 sine t times cosine t. And presumably this is just to ensure that when we find T of t, that whatever we divide by is not 0. And when we find n of t, whatever we do, because remember we have two magnitudes we're going to divide by. So this is just to ensure that neither of those are 0 when we divide by. This is one of them they already gave us, but we're really supposed to check and find this ourselves. All right, so to find, just to recall what the formulas are, we're going to find T of t, which is equal to r prime of t divided by the magnitude of r prime of t, and n of t which is equal to, and please be careful when you find n of t, make sure you are using t prime of t. So you're not supposed to be using t of t, you're supposed to be using t prime of t. So don't forget to take the derivative of whatever you found here. So you have to find t of t first, find n of t, and the magnitude of t prime of t. All right, so those are the two things that we have to find, but first they want us to verify that the magnitude of r prime of t is indeed 3 sine t cosine t. So let's just start by finding r prime of t. So r prime of t is going to be 3 cosine squared t times negative sine t. So negative 3 cosine squared t times sine t. And then here we're going to get 3 sine squared t times cosine t. So 3 sine squared t times cosine of t. Now we need to find the magnitude of this vector. So the magnitude of r prime of t equals the square root of this square plus that square. So we're going to get 9 cosine to the 4th of t sine squared t plus 9 sine to the 4th of t cosine squared t. Now let's simplify that. That equals, so we can factor out a 9 from both terms, we can factor out a cosine squared from both terms, and we can factor out a sine squared from both terms. So that gives us 9 cosine squared t sine squared t times, when we pull out the 9 cosine squared t sine squared t from here, we're just left with cosine squared t. And then plus, when we pull out the 9 sine squared t cosine squared t here, we're just left with sine squared t. And we see our favorite trig identity. We can change that to a 1. So this just becomes the square root of this quantity right here, which is a perfect square. So this ends up being 3 times cosine of t times sine of t. Oh, and that's where this comes in as well, is to ensure that when we take the square root, we don't have to put an absolute value on here. We know that this is positive on that interval. All right, so now only thing we've done is verify this. Now we still need to find these things. So we already have r prime of t, and we already have the magnitude of r prime of t. So we're just going to take this vector right here, r prime of t, divided by its magnitude, and then that will give us our T of t. So we have all of the things we need for T of t. So T of t equals, so this first component divided by that is going to give us, so the 3's will cancel, which end up with a -1. The signs will cancel, those will go away. And then one of these cosines will cancel with that one cosine up there. So we'll just end up with a negative cosine of t. For the first component, and then the 3's here are going to cancel. This cosine will cancel with that cosine, and this sine will cancel with one of those sines, and we're just going to end up with sine of t there. All right, next we need to find n of t, which means we're going to have to find t prime of t first. So t prime of t equals the derivative of negative cosine of t is just sine of t. And the derivative of sine of t is cosine of t. And then we have to take the magnitude, oops, can't see it anymore, but our formula says we need to take the magnitude of t prime of t. So the magnitude of t prime of t, we're going to use our favorite trig identity again. This ends up being sine squared of t, the square root of sine squared of t plus cosine squared of t, which is just the square root of 1, which is just 1. So now n of t is t prime of t divided by the magnitude of t prime of t. So that for us, n of t is just going to end up being the same as t prime of t. So this divided by 1, then that divided by 1. So sine of t, comma, cosine of t. All right. So I'll stop there on that video because the examples from this section are all kind of lengthy. And this one was lengthy, but they can get longer. So it worked out nicely. Like this magnitude was 1. So that made the second part of this a little bit shorter than the first part. But as you can see, these problems where you have to find the unit tangent vector and the unit normal vector can be lengthy problems in general.